Welcome to the HVAC Engineering-Techie channel. This is the channel where we talk all things HVAC, from engineering design, construction, equipment, systems, test and balance extensively, controls, efficiency, and system performance. This video is intended to be educational in nature to help you advance your career. Today, we're talking about tab instruments and tools. This is a short video, but it has some information that you need on the kind of tools you use and how you take care of them. So before we get started, I'd like to ask you a big favor. Would you mind becoming a subscriber to this channel if you haven't already? And just hit the subscribe button down below and the like button. It costs you absolutely nothing. It's absolutely free. It's painless for you. And I will never contact you. I'm not trying to get your data. The reason I'm asking for that is Google uses those to evaluate this video on their channel. So you can really help me out by doing that, and I would appreciate it. All right, let's get started talking about tab tools and instruments. So now let's talk about tab instruments. Tab work is performed by utilizing several different kinds of instruments to take and to do air and water readings. These instruments all have traceable accuracy calibrations that are done at specified intervals. These instruments are fragile and must be handled correctly to remain in accuracy. So you don't go down and get a $1,500 instrument calibrated and throw it in the back of your truck. You need to keep it, realize that its accuracy depends on how it's handled, so treat them with care. All right, airside instruments. We have velometers. And velometers basically read air pressure, velocity pressure. So we read the pressure. We have different kinds of velometers. We have pitot tubes, which are used to take pitot readings in duct. And the pitos are intended, they actually read total pressure and static pressure separately. So you can read all three. You can read total pressure, static pressure, velocity pressure. We have velocity grids, and these velocity grids basically are used to take readings on wall louvers or coils or things like that, that there's no other instrument we have that takes an accurate reading. Capture hoods, and these capture hoods basically are used to capture air out of grills and registers. Work very well. And there's air pressure gauges. There's temperature meters and probes that take different kinds of probes and do different kinds of temperature. We have duct temperature, water temperature, surface temperature, air temperature, all those different ones. Surface temperature meter, we have these infrared meters that we can use. Humidity meters to read the humidity in the air, sound power level meters, and particle counters, and air quality meters. These are all the different kinds of meters we use. There's lots of different manufacturers available for them. And depending on which specification says, or on your certification agency, what the accuracies of all these instruments need to be. Most of them nowadays were pretty close, but you do need to make sure that you're buying the right instrument that meets the calibration accuracy of the group that's certifying you as a tab technician. Then tachometer, rotational speed meters that are able to read how fast a fan or something else is rotating. It's important to buy the best quality instrument you can afford. It has to be within the accuracy ranges as specified, and you have to buy those to meet the spec. Instruments with water side instrumentation, care must be taken to not overpressurize the sensor, and actually air sensors are the same, but water is much more susceptible to damaging the sensor by overpressurizing it and affect the instrument accuracy. Some instruments come in different pressure ranges depending on what you're doing. So water side instruments are hydronic differential pressure meters, and these are electronic. They still have they actually have a gauge block built into them, some of them do. And you need to be careful to make sure you don't ever pressurize a gauge. We have hydronic pressure gauges. And of course, these you have to buy them in the different ranges that you want to have. Hydronic temperature meter probes to do water readings. TDS meters, pH meters, antifreeze hydrometers to tell how much glycol there is in a system. And then require readings for electrical motor or unit data. And these instruments are different kinds of electrical instruments required, but most of them are a true RMS meter. And we'll go through this. This electrical RMS meter, that's root mean square, multiple meters, and electrical current meter probes. Now what this RMS is always telling you is that it's actually reading the area under the curve and not just the curve itself. And the reason for that is some of the electronic gear we have can distort the sine wave. And if you don't have a 2 RMS meter, it'll give you the wrong reading. It can be 30% off. So you need to make sure you have a 2 RMS meter. And of course, this is a digital voltmeter in it. You can also buy amp clamps to go with the meter. There are combination meters that are both voltmeters and amp meters built in the same meter. There's electrical probe detectors, tickers we call them, that basically make a noise and run up a light when they get close to power, so you can tell if power's on. Other instruments are humidity meters, CO2 meters, rotational meters. Then there's certain hand tools that you need. Drill motor, of course. You'll need drill bits. Always these multi-diameter bits are always handy for drilling in panels if you need to do that. And then hole plugs. This is a tool that only you need. Only tab guys need to have these plugs to fill the holes when you make pitos and duct. Now, I do need to caution you that the plastic plugs are good most everywhere, unless you're drilling into a stainless steel duct or a fiberglass duct that may have acid in it or some other chemical that the plastic won't do. So it may need to be stainless steel. And you'll have to coordinate that with your customer to see exactly what you need. These are cheap. You can buy, for $10, you can buy 1,000 of them or something. You'll need screwdrivers, different kinds of screwdrivers. You'll need adjustable wrenches, and you'll need a socket set. And the reason you need all this is if you have to adjust fans, you may have to adjust the fan belt, you may have to move a motor, you may have to do some of that kind of thing to get the balance where it needs to be. And you'll need to take covers off equipment to be able to get to stuff. You'll need socket sets and pliers, hammer, tape measure, and electrical insulated tools, screwdrivers, wrenches, and pliers. This and nut drivers. And these are to be safe when you're working around electrical gear. And then, of course, a camera is always handy. Flashlights and work lights. These are really handy nowadays. And then you need a camera. If you have a cell phone, of course, you got a camera. But all those things you need is kind of the tools you'll need to be an effective tab technician. So how do you care and handle precision measurement instruments? So you're responsible for keeping the tools in good condition and making sure they're well calibrated and in a timely manner. Now, most instruments are required to be calibrated annually, but some jobs may be required that you calibrate it before you start that job. And you need to have proof of calibration in the form of a calibration certificate. So you need to lubricate instruments, approximately prevent corrosion. You need to clean out fluids from hydronic instruments after each use. You need to store instruments in an appropriate environment. Do not carry instruments in truck toolboxes for extended periods. They need to be on the seat. Somewhere that a human being would do okay, they'll do okay, but don't carry them in the back of the truck. I mean, I've seen control technicians want me to use their electrical meter that's been in the back of the truck for 10 years. So all beat up, scarred up, never been calibrated. And we say, no thanks, we'll use our own. Know how to properly handle instruments during use. Always put instruments back into their cases after use. Check all tubing and attachments for damage daily. If you have pressure tubes and they get a hole in them, now you're not accurate anymore, so you need to make sure the tube's in good condition. Charge the batteries after each day if they're rechargeable batteries. All this is important. Spot check calibrations by comparing similar instruments to the same reading. So if you have 2 hoods and you're curious about one, take 2 hoods and do the same reading. Now, that being said, hood's not a good example. Maybe, 2 temperature meters make sure the same. The reason hood's not a good deal, it changes with how you actually do the reading. And so if you do the reading in one position, do it in another position, it'll actually have a different number. So the one thing here is that as a technician, you're responsible to know how to operate the equipment, how to set it up, put it together, and operate it. And to do that, you have to do something we don't normally like to do, but you need to read the instructions. When you buy an instrument or get an instrument, you need to read the manual. If you don't read the manual, you may not know what it's supposed to do and how it does it. All tab instruments need some kind of periodic calibration, and you as a tab technician are responsible to make sure you're using calibrated tools. Normal calibration intervals are every 12 months. It could be 24 months on some pieces of equipment, and the manufacturer will tell you what that should be, or your certification agency may have standards that tell you what it is. Some projects may require all instruments utilized be calibrated at the start of the project. That's a project specification item. Technicians should always check on instrument calibration by checking it against another calibrated instrument. Use, misuse, transportation, or damage may cause an instrument to go out of calibration before the required interval. Now, the reason this is important is you would like to have real readings, right? You'd like it to be accurate in your report. Well, this becomes really important if you're challenged. If you're on a job that's commissioned by another and he wants to challenge some readings, he expects them to be repeatable. If they're not repeatable, now they start raising questions that maybe you don't have accurate data. And so that you don't want that. You want it to be right the first time. Exact requirements of calibration are provided by the certification agencies. Some certification agencies require NIST 3-point calibrations where required. I mean, there's some things that you can't do a 3-point on, but most things you can. And of course, a 3-point calibration calibrates it at 3 different points on its curve, and it guarantees it'll be in calibration at the full range of the instrument. Every instrument requires proof of calibration via calibration certificate and an instrument sticker. So the instrument itself actually has a sticker on it. And that's the end of tools. It was really short and sweet, but this is some information you need to know about tools. So appreciate you joining. Please become a subscriber. Have a great day, and I'll catch you on the next one.